Hello, back again. We're going to do some more Cisco subnetting problems. The typical problems that you're going to see in some of the exams or certification exams, and one of the most typical problems is they'll give you a design of a network, and the network will have a flaw in it. So there's a problem in this network, all right, and you've got to find the problem. And the problem almost always undoubtedly is dealing with somehow incorrect subnet, IP address scheme, incorrect network scheme, something like that. So here's one of those typical scenarios, and I'm going to show you how you would answer this question. So they give you the question and they say, find the problem. Computer A cannot get to the internet. Okay, so here's computer A over here. He cannot get to the internet. What's the problem, right? What is incorrect? And I didn't put like A, B, C, D, or E, but you know the answers usually are incorrect IP address, wrong networks, bad subnet mask, incorrect gateway, you name it. What's the problem? So let's analyze this problem. Okay, first of all, we've got a computer, right, with an IP address, a net mask or subnet mask, and a gateway address, right? So this computer's been completely configured, IP address, subnet mask, and gateway. And then the computer's connected to a switch, which is connected to a router. And on this interface, this router interface, is the IP address right here that's configured. And then on the other side of the router is the cloud representing the internet. Okay, so the question is, what is wrong in this scenario? Okay, so I'm going to show you kind of a strategy for how you answer this question. Well, first thing you look for is the obvious. The router's interface is 173.32.2.62. The router is the gateway. So, does the computer have the correct gateway? And if you look right here, you'll see that 173.32.2.62. So you see that the gateway is correct. Check. So he's got the right gateway. Then here's another typical problem. What if the subnet masks don't match? What if the subnet masks don't match? Over here, we've got a /27 subnet mask, and over here, the subnet mask is written out in dot notation, decimals, right? So we have 255, 255, 255, 224. Are they equivalent? Is /27 written out as 255, 255, 255, 224? Well, that's easy to solve. All you have to do, I'm going to give you the long way, is draw 27 ones. 1, 2, 3, 4, 5, 6, 7, 8. That's a 255. 1, 2, 3, 4, 5, 6, 7, 8. Another 255. 1, 2, 3, 4, 5, 6, 7, 8. 255. And then that's 24 ones. And then here's the last octet. 1, 2, 3, 25, 26, 27, 0, 0, 0, 0, 0. Okay, so 3 ones, 5 zeros. All right, now you have to know your place values. This first bit over here is the 128's place, then the 64's place, then the 32's place. So 128 plus 64 plus 32. If you add them up, 128 plus 64 is 192, plus 32 is 224. So the subnet mask is correct. So /27 is 255, 255, 255, 224. So far, we don't have a problem. So to answer this question, to figure out where's the problem in this network, it's going to be somehow to dealing with the IP addresses between the computer and the router. All right, and I'll show you how we solve that problem. To do that, in almost all of these questions, you have to be able to find the networks. Okay, so we decided that with the binary, we saw that the last octet was 1, 2, 3, and then 5 zeros, right? 224. And we know that this is the 128 bit, this is the 64 bit, this is the 32 bit, 168421. So the magic number in this case is the last one, which in this case is in the 32's place. So the magic number equals what? 32. And that tells us where our networks are. So the networks go up by 32. So we've got the 0 network, the 32 network, the 64 network, the 96 network, and this would be 0 to 31, 32 to 63, 64 to 95, and so on and so forth. The networks go up by increments of 32 because the magic number in the last octet is 32. Okay, so that means that this computer, the router, is got the number 62, right? So 62 is in the 32 network with a network address of 173.32.2.62 and a broadcast address of 173.32.2.63. Sorry, network address of 32. Network address of 32, broadcast address of 63, and the router's IP address is 62. So it is the last usable address in this network, right? But look at the computer's IP address. The computer's IP address is a 65, right? Host number 65, right? Well, 65 is in the 64 to 95 network in this subnetted scheme. In this subnetted scheme, the networks go up by 32, and there's 32 hosts in each network. 30 of the hosts are usable, and so the router and the computer are on separate networks. So you have to be able to find the networks to solve these kinds of questions. Always. Always, always, always. If we change the scenario, and we make this a /26, and we make this a 192, right? Now, in the last octet, it's a 192. You would have this scenario, 1, 1, and then 6 zeros, which equals in decimal 192. The magic number would now be what? 64. And the networks would be 0 to 63, 64 to 127, 128 to 191, and 192 to 255. And in this scenario, the router being a 62 and the IP address being a 65, they would also be in separate networks, and it wouldn't work. Okay, so it shows you kind of how important it is to be able to find the networks using the magic number to solve these types of questions. And how would you solve this problem? Change the IP address.